Hello everyone, my name is Yuliana Usman and my student ID, as you can see from the slide, it's 210 10 11 91 234, and I would like to present to you guys my assignment, and it actually an assignment for a subject in my major in my department, civil engineering department. It's called value engineering. So in this assignment, in this task, I was assigned for a case number 8. It's a value engineering study case of a project named Trunk Highway 7 at Louisiana Avenue interchange. First thing first, why we need value engineering is actually some kind of engineering study. It's through a project, a construction project that was intended to reduce the project cost. Usually, it's for a big scale of project, and you can see from the title, it's kind of big scale of project. It's a transportation project at interchange and avenue interchange, so we can assume it's a big scale project. Okay, next. First, I would like to introduce you guys about the project. This project called Trang Highway 7 Louisiana Avenue. It's located in St. Louis Park, Los Angeles, California, United States. And yep, it's an transportation project. And the purpose of the project is to remove the existing at grade intersection of Trang Highway 7 and Louisiana Avenue in St. Louis Park, and to replace it with a grade separate interchange. The improvement will include pedestrian and bicycle path along with reconfiguration of local frontage roads to improve mobility to the Trunk Highway 7 corridor and Louisiana Avenue. This project is essential for meeting transportation and safety needs of the region and is anticipated to reduce conflict to the traveling public. So, actually, why is this project was constructed? Actually, it was constructed around 2010, and it was designed in 2010 and constructed through 2011 and 2012. So the main problem is, as you can see from the picture, is that as traffic volume increase and intersection cooperation become more congested, the instant of rear and crashes is expected to increase. Further, drivers who become frustrated with waiting for long periods at a traffic signal may engage in more risky behaviors, such as running yellow or red lights and speeding through the intersection. Well, actually, it's almost all drivers through intersection behave like this. We tend to be more frustrated if we have to wait for the long period for a traffic signal, how to wait for the red turns into a green light. So the purpose of proposed Trunk Highway 7 and Louisiana Avenue interchange project is to address deteriorating safety and operational condition. These deficient conditions are resulting in numerous crashes and causing high levels of congestion. The project is also intended to improve pedestrian and bicycle movement across Trunk Highway 7 that are anticipated to increase with the construction and operation of a future LRT station along Louisiana Avenue. Lastly, we could say that this is anticipated that the transportation improvement will have foster economic development in the area through the area of Louisiana Avenue in LA. So, after the value engineering team go to the site and identified about this project, they identified this following constraint and controlling decision during the investigation phase of the study. First, they must accommodate bicycle and pedestrian using construction, and in the proposed design, they had to avoid impact to the Louisiana Oaks apartment complex. They had to avoid impacts to the Sam's Club, avoid impact to the railroad overcrossing. They tend to decided to close right access to Trang Highway 7 at the east end of the project. And this project is slating is scheduled for November 2011. By March 2012 funding obligation date, there is a potential for a 1 year extension with a prior approval by Met Council. They have to minimize right of way impacts and acquisition, and they had to minimize excavation, environmental assessment, and impact to the floodplain will need to be mitigated. There's no net document is scheduled to be out by. And there's no net increase in 100-year float elevation. I'm so sorry for that. And then there's a strong desire not to impact the pump station and the medical office along Lake Street, because along the road, along the avenue interchange, there's a few pump station and also the medical office, and they would like to try not to impact the medical office along the Walker Street. And the last thing and it's not the last thing, they would like to avoid any impact to the 4F properties, and they would like to minimize impact of the SW quadrant of the proposed interchange. So they got through the analysis of this project, and there's a few identified issue when they do the study and they do the site visit. The problem that they get, the issue that they got is the proposed profile on Trunk Highway 7 west of Louisiana Avenue will create a roller coaster effect. And there's several utilities at the intersection, and also existing field condition. The roadway location is different because the geotechnical data from initial construction, they got it from 30 years ago. That's why they need to investigate it more. And there's a very tight condition for staging construction and traffic. This living Louisiana Avenue also can be handled by a single lane in the proposed design. And there's a bus route along the Walker Street, and the current signal cycle length is too long. This is one of the main problem it is. Okay, so through the project analysis, as we all know about the value engineering, they use a few tools, and in value engineering itself, they got a few tools. But in this project, they use four tools. It's the cost model, the functional analysis, the phase diagram, and the matrix performance attribute. It's a value and matrix performance attribute. So first, they use the cost model. Okay, why this cost model is important? Because we need to know the estimated cost for this project, and they model this cost. The model are organized to identify major construction element or trade categories, the designer's estimated cost, and the percent of the total project cost for significant cost items. The cost model clearly showed the cost drivers for the project and were used to guide the VE team during the study. As we all know, if we want to model some cost for the construction project, they use the higher item that use the most cost in the estimated cost of the project. So as we can see, the items roadway uh use a total of 30% of the whole cost for the project, and they model it, they organize it. The one is the higher one. We model it at the top, and through the bottom they chose the eight most, we can see, expensive items through the whole item of the construction project. Okay, next, they use the functional analysis. The result a unique view of the study project. It transforms project elements into function which move the VE team mentally away from the original design and takes it to what a functional concept of the project. This functions is defined in verb noun statement to reduce the needs of the project to the most elemental level. So we can see there's a few items that we need to know what is the function. They analyze the function as the item bridge, what is the verb, what is the noun, the artwork, the retaining walls. We need to know the function so that they could be analyzed. And the third tool is the fast diagram. The fast diagram for the project show reduce conflict, improve mobility, and create access as the basic function of this project. Key secondary function include construct, interchange, and stage construction. As you can see, they provide the reduced conflict from how to why about why this project is constructed. And the last tools that was used is the value and performance metrics attribute. Along with the project team, they identified and defined the performance attribute for this project, and then they define the baseline concept against this attribute. Performance attribute represent those aspects for a project scope and schedule that may process a range of potential values, which we can see through the diagram, about the value matrix. Which attribute is more important to the project? It's the mainline or the local operation maintainability through the risk. We've got a total of 100%, while the value metric we could see which the most potential values. Then okay, And then through this whole diagram, through this whole item and value and performance, the value engineering team do some analysis. Okay, see, this is the study result. After the value engineering team do the study, they generate 48 different ideas for this project. These concepts were compared against the best and that was developed by the project team. The concept that performed the best were further developed by the value engineering team. From this idea, the VE team developed 8 recommendations, resulting in a net cost saving of 3.9 million to 5.1 million dollars and overall of performance improvement of 7 to 11%. This is the best scenario. This is the best thing that could happen to the through the project through the value engineering study, which they reduce the cost while they improve the performance, they improve the function of the project. This is a good scenario one. So the individual recommendation are summarized. Okay, there's 8 recommendation, right? So the first is ground improvement for 1A, 1B, and 1C. All of this is the same. It's about the ground improvement. So for 1A, they use ground improvement technologies such as deep soil mixing, stone columns, or other types instead of excavating muck from under Trunk Highway 7. And for the 1B is they use a lightweight fill. For 1C, they use the pile supported fill. And then value recommendation number 2, they use the reinforced slope. They replace cantilever walls with reinforced steepened slope where ROW is permitted. So number 3 is the single lane roundabout. So they would like to use the roundabout through the lane. They construct both roundabouts on Louisiana Avenue as single lane roundabouts. The Louisiana Avenue roadway connecting the roundabout should be designed for a single lane in each direction with the option to expand in the future when necessary. So the concept is that they use the single lane while in the future they could maybe they could use two lane if the volume of the roads is increased. Number 4 is they remove median on Louisiana Avenue. They eliminate the raised median on Louisiana Avenue in order to give the roadway more urban character and to potentially provide some measure of traffic calming and less impervious surface. Number 5, 5A and 5B, it's about the design. So the number 5 is the design. First, they use a tight urban diamond interchange. For the design interchange, they use a tight urban diamond. Actually, there's a few interchange that use this kind of design, a diamond shape. So, using the same plan and profile as the baseline idea for Trunk Highway number 7 and Louisiana Avenue, construct a tight urban diamond interchange. And for 5B, they would like to use a single point roundabout interchange. Using the same plan and profile as the baseline idea, they construct a single point roundabout interchange. This would be done instead of button hook ramps to roundabout to accommodate the ramp traffic from Trunk Highway 7 and Louisiana Avenue. Okay, you can see the example through the picture. Situate. It's a single point roundabout interchange. Okay, so let's take a look at of the implementation strategies. Because of competing recommendation, 3 different implementation strategies or scenarios are available. Recommendation 1A, 1B, and 1C all offer different ways to construct embankments. Recommendation 5A and 5B, as I said before, are both differing types of interchange than the baseline concept. So we could see there's a 3 different scenario. As for um recommendation number 1A, 1B, and 1C, they use all of the 1A to number 2 for the scenario A, B, and C, because this is the main point. I mean, it's not the main point, it's the uh yeah, it's an important thing that they use. As for the scenario A, they use the recommendation number 3, number 4. Scenario B, they use the recommendation number 4 and 5A. While the C1, they use 4 and 5B. Okay, these 3 different scenarios result in 3 different cost estimated saving value. You can see by comparing the performance and the cost suggested, which recommendation are potentially as good or better than the project baseline concept in terms of overall value. Comparison at the value index level suggests which recommendation have the best functionality per unit cost or provides the project with the best value. So as you can see, they use the overall performance of scenario number 1, 2, and 3. Okay, this is the scenario A, B, and C. It's the same as of scenario 1, 2, and 3. you can see at the percent of the value improvement. The best one is scenario number two. The value improvement is a total of 55%. Okay, that's why they use the value engineering choose scenario number two, which they use the tight urban diamond interchange. So, I would like to explain to you guys what is an example of the recommendation. So for this case, I choose value engineering recommendation number one for the for the ground improvement, or Indonesia we call it perbaikan tanah. Okay, as for the ground improvement, I would present, I would explain to you guys about the original concept, the recommended concept, and also advantage and disadvantage of this recommendation. So, for value recommendation number one is about the ground improvement. The original concept is that they would like to remove contaminated soil and muck and replace with a burrow. It is assumed to require temporary sheeting and shoring to maintain a stable excavation. Depths are expected to be around to be up to 35 feet for removal in West Bridge area. There's another assumption is that the mineral soils and organic materials that are encountered will be contaminated with coal tar or other cresceo-type products and byproducts. That's why the value engineering team do an analysis through this concept. Okay, so they recommend three different concepts. They choose three. They implemented these three different concepts for the ground improvements. For the 1A, they use ground improvements technology rather than excavating muck. The recommended is that they use a deep soil mixing in lieu of excavation. They use stone columns, vibro compaction, and densification. As for the 1B, they use lightweight fill, EPS geofoam or shredded tires, and bridge over compressible materials with a lightweight fill embankment. And the 1C, they use the pile supported fill, drive or install piling, or could use auger cast pile or stone column as well as the column as well as the number 1A in the area. I'm so sorry. In the area which compressible soils are present to spread over the problem materials, construct a reinforced soil mat over piles to support the roadway bridge approach embankments. Okay, so we could see through the advantage for recommendation number 1A, they reduce disposal of contaminated soil, may have preservation effect containing contamination, and then potential to reduce construction schedule. I'm so sorry. And they also reduce borrow or no backfill of my excavation, reduce truck traffic in corridor. So this is some kind of a good advantage, and there's potential to eliminate surcharge periods and potential reduction in noise levels, and eliminate or significantly reduce settlements. As for the recommendation 1B, they reduce settlements, reduce borrow or field truck traffic during construction. They reduce excavation of mud and reduce construction schedule, and it's kind of easy to construct. As for the 1C, they eliminate excavation, reduce construction truck traffic for halting away and borrow to the site. They reduce long-term maintenance by eliminating long-term settlement. The temporary sheeting not needed for excavation, the less risk and lower cost of a base, and much more predictable over the base, and the no extent of contamination and mark removal. This is kind of good advantage to the recommendation. Okay, as for disadvantage, number 1A, they may require specialty contractor and performance specification, and risk of soil wave. Okay, there's a risk of soil wave outside the embankment area, but it's quite not that disadvantage. As for the 1B, they make complicated design of other items need for the detail, guardrail, and movement slab. And also the potential risk associated with foam or petroleum mix and contaminated soil. Robust cover requirement will be necessary, and it would preclude utilities from entering field area. As for the disadvantage for the value engineering recommendation number 1C, there's some noise because there's a pile driving versus sheet pile driving, and may need to be coordinated with the sheet piling that will be needed for bridge construction. So let's take a look at the cost summary. Original concept for all this ground improvement is $4.4 million. And okay, let's take a look for the recommendation concept. 1A, 1B, and 1C, there's some kind of reduce. So the estimated saving costs as you can see below. For 1A it's 2.4 million, 1B 2.2 million, 1C 2.5 million. So that's all for the cost summary for value engineering number one. And I'm sure for the value engineering number two, three, four, and 5A and 5B, there's also some kind of original concept and recommendation, advantage, disadvantage that truly it's a good one because they choose the best 8 ideas from the 48 ideas from the value engineering team. Okay, let's tackle from the conclusion. Value engineering study for this Trunk Highway 7 at Louisiana Avenue interchange generate as much as 48 ideas, as I said before, which 8 of them were chosen and implemented. And there are 4 value engineering tools that were used through this whole project analysis. It's cost model, fast diagram, the function, value, and performance metrics. And the result of the idea produced 3 different scenarios, resulting 3 different results of cost saving and performance improvement. The chosen one is that the scenario is the most cost saving scenarios, and the total estimated cost from the chosen idea is about 3.9 to 8.5.1 million dollars. So that's it. So that's the whole conclusion. And yep. Thank you for watching this video. Thank you for watching this presentation. I'm sorry for all if I didn't explain it truly. And I hope the study engineering case at Trunk Highway 7 at Louisiana Avenue could give you some ideas, could explain to you better about value engineering so that other project could be this value engineering could be implemented through a through many more projects, especially in Indonesia. That we could say there's not as much as many value engineering that we could see in some project in Indonesia. So that's all from me, Yuliana Usman. I would like to say thank you again and goodbye.